Okay, the second video lecture in this series is about volume, so measuring volume. This is another item that you've probably studied in some detail growing up in different science classes. So what is volume? Okay, we can define volume by saying it's the amount of space an object occupies. A lot of times you'll hear them say volume is how much space something takes up. Okay. So I like to say the amount of space an object occupies. Those definitions are both the same. I just don't like to end a statement with a preposition. So what is the standard unit of volume? It is a liter. The abbreviation for a liter is a capital L. Really important to understand that it is a capital letter L. Okay. What are some tools that we can use to measure volume? Take a look here. Okay. We can have a graduated cylinder. Remember we talked in class, something is graduated when it has those measurement marks on it. Okay. So here's an example of a graduated cylinder from this class. I know my drawing isn't the best, so it doesn't look exactly like this. But we have something called a graduated cylinder. It has a flat base down here so that it can sit upright on a table, and you can see down inside of it there. This is a 50 milliliter graduated cylinder. It measures up to 50 milliliters, which this is, a normal size that we would have in here in this class. You can see the graduation marks along the sides, okay? This measures liquid volume, and we will also talk about a process called water displacement that we will use graduated cylinders for. Water displacement, we try to find the volume of objects like a cylinder or a marble or different things like that without actually having to bust out those geometric formulas for them. Another object that we will use is a beaker. And remember when we were talking about equipment and tools, we said that graduated cylinders are way more accurate. I apologize, that keeps going in and out. Way more accurate than a beaker, but we can get, a pretty basic understanding of the amount of something that we have. Again, we use this to measure the volume of liquids. Okay, we know that we can use beakers to hold solids and different things like that. But we really want to look at volume of liquids with these. You'll see this goes from 50 to 100 to 150 to 200. There are those graduation marks in between, so this would be 50, 75, 100, 125, 150. There aren't graduation marks in between that. That's why this is so hard to say that this would be accurate if we were trying to measure out, let's say, 90 milliliters. Okay, this is another example of a graduated cylinder. You can see these, and this ring is upside down on here. We have graduated cylinders that have rings on them, and it makes it way easier for us to read the level of water that we have in them with one of those tools. Okay. Well, how do we measure solid objects? Well, we know that we have those great geometric formulas. If we have a cube, length times width times height, so we can use a ruler as well in this class to measure volume. Okay. Just some little metric conversions here or things to understand. 1 milliliter is 1/1000th of a liter. Think back to that metric chart King Hector does drink chocolate milk. 1 liter is the same thing as 1,000 milliliters. Okay, so a liter is obviously way larger than a milliliter. 1 milliliter is equal to 1 centimeter cubed. Notice this milliliter measures the volume of a liquid. This centimeter cube measures the volume of a solid. Okay, 1 liter is a liquid value. 1,000 centimeters cubed is the measurement for the volume of a solid. Okay, this conversion factor right here will be very important for you throughout the year. You could look at a graduated cylinder if we go through this process of water displacement, and you'll be able to say, hey, if the difference here is 10 milliliters, I know the volume of this object that I've put in here is 10 centimeters cubed. Okay? So measuring volume in graduated cylinders is pretty simple. We fill up to the line for whatever volume that you want, okay, 40, 50, 22, 25, whatever you want in terms of volume. But there's a process we use when measuring volumes called water displacement, and we're looking at the volumes of irregularly shaped objects, okay? And how do we do that? So I've drawn some generic graduated cylinders here, so just some little illustrations. And the main idea here is, hey, I'm going to start out with a known volume of water in my graduated cylinder, and I'm going to add something to it. You could say, okay, I'm starting out with 25 milliliters in this graduated cylinder, and I could add a crayon to it, because how hard would it be to find the volume of this crayon just using a ruler and using some math? Because take a look at the tip of this. That'd be kind of hard to do. It's rounded, all those different things, okay? You'd be using a lot of different formulas, okay? So I'm going to start out with a known volume of water in my graduated cylinder, okay? I'll mark that volume down, okay? Notice I'm saying that I started out with 15 milliliters, okay? I added my object, okay? And so we'll stay with, hey, I've added this crayon to my graduated cylinder, okay? The water level went up. So it went from where I started with 15 milliliters to 22 milliliters, okay? My water level rose. I will mark down that new volume. So I've marked down 15. I've now marked down 22. Okay, well, what does that tell me? Well, the difference between the two of those values, 22 milliliters and 15 milliliters, gives me the volume of this crayon or whatever object I've put in there, okay? The volume of the object is the difference. So I would want to say my final volume minus my initial volume gives me the volume of whatever object I have put into that graduated cylinder, okay? So 22 minus 15 gives me 7 mLs, and we know that this is liquid, so I could say, hey, this is also equal to 7 centimeters cubed. Okay. Something that I do want to point out, when you are reading volume on a graduated cylinder, okay, water is not going to give you a level that is straight across, okay? We have to understand that on a graduated cylinder, it is going to be a little bit of a dip, and we call this the meniscus. Okay, that is the meniscus. Why does this happen? Because of cohesion and tension within the particles. Those water particles try to stick to the sides of the container. This is called a meniscus. We want to read the volume from the very dipped down part here. Okay, when you are measuring volume with a graduated cylinder, always place, I'm going to say GC for my graduated cylinder, on counter. Move yourself down to make the meniscus eye level, okay? Always do this, leave it on the counter. If you're holding the graduated cylinder up in the air, you might have it tilted a little bit. Leave it on a flat surface. Crouch down a little bit if you're taller so that your eye level. So here I am with my artist attempt here. This is my eye level, and I'm reading directly whatever is listed at that meniscus point, okay? That is measuring liquid volume, water displacement, and what are some tools and units of measurement for volume.